Hi, this is Steve Hodges with SRR Technologies. We will be taking a look at the current state of voice over IP. As you can see in this drawing, it's all over the place. You have some companies that offer conferencing, other companies that offer an IVR. You have some companies that put together some pretty decent systems that encompass a lot of it, but very few systems encompass it all, and almost none of them have optimization done in mind, whether it's the reduction of packet or packet size. We take a look. VoIP technologies have become stagnant in how it's used for both voice and data transmissions. Companies that could make a difference will not, because it's not in their best interest. Individuals and corporate privacy is not a concern or focal point for systems. Over the past 10 years, while other technologies have taken leaps and bounds, and voice over IP has gotten much better in the feature and some of the consolidations of platforms, what they haven't done is they have not addressed security issues. They have not addressed the continued expansion and need for more and more bandwidth as the service is used by more and more people. If we take a look, voice over IP as a standard comes in and it uses 50 packets per second. It uses an 8 kilobit base, and that's best case scenario in the open market with the telephone companies today. Other options are available, but not always used. When you take a look at this as we go through the demo, in the last demo we did, we used Wireshark as our validation tool, and we have a web link posted so people can see the results of that first demo. SRR Technologies, why are we different? We take the end user into consideration as part of the solution instead of something out there that can just be taken care of by somebody else. We've also taken the core system and built all the functionality straight into it to include bandwidth optimization. If you take a look here, all of the processes are put into 3 simple units. The core processor does interface to all of the real world across the voice over IP itself, and has optimization built in and has security built into every aspect of what it is. The core processor does intelligent routing, and the client handles the client interface. We take a look here. This is our smartphone. Now in the smartphone, we take it and we work with it more from a modern screen technology used for the cell phones, where everything's at your fingertips. You can bounce around and move around, and we've incorporated that into our thinking here. We take a look at the systems that we offer. We have the main screens that come up, phones, all these different aspects, and all of these different features built into this phone, and standard features don't offer that. So what we're going to do right now, we're going to break out of this, and we're going to come over to our demo. In our demo, we already have our phone up and running, and we had already ran a test call on it. So this is our main launchpad. When the phone comes up, it's going to look this way. We have access to our phone, a social network. We can go out and find and look for things not just under Google or Yahoo or MSN, but under any of the different things, LinkedIn, Indeed, all the different job networks, and this is all controlled by local files on the computer. We can go in and do a quick launch for a calculator. We like that. We're going to be using it during the demo anyway, so we might as well pull it up there. Then we have this really cool tool, and it shows us what we're doing with our packets, and we give you the ability to turn off the packets and allow it to just run just like any other standard phone on the network. But why would you? It's simply there for demo purposes only. You don't want to do this during a real call because you're trying to save packets, not increase how they're used. We have a very simple series of setups. Most by default are what you're going to need to do. So with this set, whenever you're making a public call, you make sure your voice is set, secure voice is set to none, because it won't work. It'll kick back and the carriers say, hey, we can't do this. They'll complain. Then your voice codecs, you can turn on any codecs you want. And each codec has different options. As you can tell out here, different options, different codecs, but most aren't supported on the open network today. Miscellaneous, we can come in and we can do screen pops up, and we can do self audio test to make sure we have the speaker and microphone connected to the phone. And as you can see, you can hear right now. So we're going to turn that off. So let's go back over to our main screen and let's run a test call. During this test call, this will be a test call from our phone to the public network. Now, if you saw the other link that we did earlier using a off-the-shelf product, all you see is 50 packets per second in from the carrier, 50 packets being transmitted back. So everything is based upon a 50 packet per second, which is, by the way, industry standard. Another thing that the other video showed you was it was using G711 as the codec, which for those who don't know, it is one of the highest bandwidth hogs when it comes to using voice codecs and compression. And at the level we're talking about it, both at here and in the back end, it is not any real benefit except for providers who get paid for the amount of internet you have to buy. So we'll take a look at this. Now there's going to be a period of silence as we go through this, and in the next call, we're going to go from one call to the next. We'll take a slight break, but when the next call, we'll do a SRR Technologies to SRR Technologies call, and we'll see that the bandwidth just drops through the floor. I mean, the only reason you're going to see any bandwidth use is because we're going to say something so you guys know we have an open mic, so that we're not mucking with anything or doing anything with that. So with that being said, we're going to go ahead and we're going to prep it here. So we're going to dial. Now that's my cell phone. We're going to go to answering machine, and it's going to the exact same test we did with the other phone, but what you're going to see here is that the carrier is going to transmit at 50 packets per second, and we're going to transmit whatever picks up based on background noise or background noise, because I'm going to try and be pretty quiet during this next section. You will hear the recording coming from the phone company telling me, hey, enter an option, and finally it'll drop the call. So here we go.
To listen, press 1. To change your greeting, press 3. To access your personal options, press 4. Main menu. To listen, press 1. To change your greeting, press 3. To access your personal options, press 4. Main menu. To listen, press 1. To change your greeting, press 3. To access your personal options, press 4. Goodbye.
So the phone company has just dropped the call because we didn't do anything within it. So let's go ahead and stop here. Now what you saw here was this guy, which is what we were receiving from the phone company, was pegged out at 50 packets per second. And this guy, he died out at about between 4 and 6 packets per second. At one point you saw it jump up in the amount of packets per second because I actually wanted to show that there was an open mic during this transmission. So let's go ahead and go back to the main phone, and you can see that it was closed. And we've already stopped our Wireshark, so let's go in and look at our specific capture on Wireshark and go for our voice over IP call. Now this is the same test we did before, and again this is the same tool we used to evaluate what we did. And here we did 210 packets at 38 seconds, and there were a total of 2146 for 43 seconds. So if we go ahead and we take the 20 now, let's clear that out. The 2164 and divide it by 43.277, you'll see that it's right at 50 packets per second now, and that is going from the carrier to us, and that matches what our meter showed us during the live call. Now if we go ahead and we clear this one out and we go 210 divided by the, now it's the total length of the call. This is the total length of the call. You don't always see the packets and time, so we have 43.277 equals 4.85 packets per second. So when you take a look at it, you had a 50 packets per second, and then you had a 4.85 packets per second, with us transmitting 210, and that's when I was doing my packet transmit. And the phone company during that same time period was transmitting 2,164. Now, it was time periods of silence waiting for us to do things, but during that time period, it should have not transmit anything in between those points, so you should see lower amount of packets if they're doing bandwidth optimization, and they weren't. And so as you're looking at how things are handled differently between the carrier and our product clearly is superior when it comes to packet optimization. And you don't have any other phones out there on the market today that are doing that. Now, another aspect of what we wanted to test during this call was a point-to-point call coming from our equipment to our phone, and that's what we're going to do right now. We're going to a call to come into this phone. We're going to answer it, and we are going to see the difference in how that is handled. Now, again, there will be a period of silence, and there'll be a time where I do a test, which, since both mics are near me, you're going to hear it come from both ways. You won't hear what happens coming from the phone company. None of those packets will exist. So we're going to go ahead and get quiet and do this test, and we'll do it for about 30 seconds of silence, so bear with me. Went ahead and ended that test, and we had some background noise pickup, which is perfect because the mics are open and susceptible to that. So you'll get a chance to see how that functions. Now, another thing that you're going to see here is the fact that these are secure calls. In the regular calls, you didn't have anything that was showing that it was a secure call. So as you take a look, you look for SRTP, or secure communications. Now, let me go back over to my phone and get my calculator real quick. So as I'm taking a look at the call itself, the first thing we want to notice is different is that it says SRTP. So this is Secure Real-Time Transport Protocols, or Secure Voice. You don't see that in any other demo that we do, and you won't see it when you replay this one because it doesn't exist. Now, within this, you can see that coming from the call that originated this was our other computer that has another desktop phone on it, and it comes down, and you can see that it transmits 147 packets. Well, the mic on this one's a little hotter, so it tends to pick up a little more background, so you see 315 packets. Now, the real question is, during a 42-second run, what should we have seen? So let's take a look and find out what our packets per second were. We're going at 315 divided by 42.778 equals a 7.3 packets per second is what we put out during the length of this call, which is right about what we saw that we were transmitting. So let's go ahead and clear that one out, and then we had 147 packets divided by 60, and now let's clear that out. We know that's not right. We had 147 packets divided by 41.081, and we get a 0.3.5. So the overall packet reduction is greater than 90% for the total length of the call. SRR Technologies has taken into consideration features. As you can see in this soft phone, we use the latest in what's considered smooth technology. We go in, we integrate so that the user doesn't have to think about it. The bandwidth saving and optimization. Now also in the last one, you saw the GSM codec being used, which is fantastic. It's a lower bandwidth codec. It's not quite as good as what we consider G729, which is a paid-for codec. If you want that extra lower bandwidth, yes, you have to pay a licensing fee to get there. There are other codecs that actually go lower, but they're not open and available within the industry. This concludes this portion of our demo for right now. SRR Technologies is striving to give the customer exactly what they need and automatically set up to keep it simple for them. And if it's simpler to use and it's automated, then you're getting the most for your money.